In 1942, this man built the world's first nuclear reactor. This is Enrico Fermi, an Italian physicist who won the Nobel Prize for his work on quantum theory. But he is perhaps best known for his creation of the world's first nuclear reactor, which he did in just 27 days after the United States entered World War II. And it's not even that complicated. It consists of just two parts: a big sphere made out of graphite, and one small thing that is missing from this picture. Can you guess what it is? Well, if you guessed a ball of uranium, you would be correct. When Fermi and his team arrived at the University of Chicago, they found a huge pile of uranium that had been stockpiled by the U.S. government. The plan was to use this uranium to create an atomic bomb. However, in order to build a bomb, you need highly enriched uranium, meaning that you need to separate the fissile uranium-235 from the more common uranium-238. Otherwise, the chance of any single uranium atom undergoing fission when it gets hit by a neutron is just too small to sustain a chain reaction. So instead, Fermi decided to use the uranium as is and see if he could get it to sustain a chain reaction without enriching it. He set up a meeting with the dean of the university's physics department to ask for some graphite. Graphite is made of carbon atoms, which do not interact with neutrons very well. So Fermi thought that it would be a great material to use as a moderator, slowing down the neutrons produced by the uranium so that they are more likely to cause fission. But little did he know that the dean had recently installed a new safety protocol which required him to obtain approval from the university's Radiation Safety Committee before handling any radioactive materials. So he had to wait around for a week until he got the authorization to use the graphite. In the meantime, he started assembling the pieces of his reactor under a football field to avoid detection. Once he got the graphite, he started piling it around the ball of uranium. They added layers of uranium and graphite and surrounded it all with a thick layer of paraffin wax. This was their first reactor, which they called Chicago Pile 1 or CP1. On December 2nd, 1942, they began adding fuel rods made of uranium oxide to the reactor core. Then Fermi took a Geiger counter, walked up to the reactor, and started counting the number of pulses. At first, the count rate was low, but then it started increasing. 1 hour later, it was 200 times higher than normal. They had created a sustained nuclear chain reaction, the first ever. But why wasn't there a mushroom cloud of smoke? To understand what happened here, we need to take a closer look at what happens inside a nuclear reactor. When an atom of uranium-235 captures a neutron, it splits into 2 or more lighter atoms and 3 or more neutrons. These neutrons go off in different directions and can cause other atoms of uranium-235 to split, and so on. This is the process of nuclear fission. Each time an atom splits, it releases energy. And if the number of neutrons produced by each split is greater than 1, then the chain reaction is said to be self-sustaining. In this case, each uranium-235 atom that splits produces an average of 2.4 neutrons. But something else interesting also happens. Each split releases a tremendous amount of energy, about 200 million electron volts per neutron. That's equivalent to the kinetic energy of a fast-moving baseball. All this energy heats up the water that surrounds the fuel rods, which turns into steam. The steam spins a turbine, which generates electricity. So in essence, nuclear reactors convert heat energy into electrical energy. So why didn't they blow up? Well, the graphite moderator slows down the neutrons, making them more likely to cause fission. But it also has another effect. It absorbs some of the excess neutrons that would otherwise cause more fission and create a runaway reaction. So the graphite acts as a sort of brake on the reaction, preventing it from getting out of control. Fermi and his team were able to keep the reactor running for several hours, producing enough plutonium-239 to make the first nuclear bomb. The United States would go on to win the war, and the age of nuclear power would begin. This is the host with Minute Earth. And if you want to learn more about how the world's first nuclear reactor works, you can check out the long-form version of this video on our website.